Okay, let's continue with the rest of the questions for OS Lab Viva questions. First question is, what is process synchronization? So, in a situation where there are several processes who are trying to access and manipulate the same data concurrently and simultaneously, then the outcome of execution depends on the particular order in which this access takes place. Now, this is called race condition. So, in order to avoid race condition, we have to ensure that only one process can manipulate the same data at a time, or only one process should be able to access a process at a time. So, this technique is called as process synchronization. Next, what is a critical section problems? So, first let's look what is a critical section. Critical section is that part of a process or a code segment in which the process changes common variables, share data, update tables, write to a file, etc. So, whenever one process is executing in its critical section, no other process should be allowed to execute in its critical section. And any critical section, there are three basic requirements. They are mutual exclusion, progress, and bounded waiting. So, one of the solution to a critical section problem is Banker's algorithm is one of the solutions to a critical section problem. Next, what is semaphores? So, semaphores are synchronization tools that helps to solve this critical section problem. Semaphores are integer variables that apart from initialization can be accessed only through two standard atomic operations, wait and signal. Next, what is a bounded buffer problem? So, in a bounded buffer problem, we assume a pool that consists of n buffers, and each buffer would hold one item. So, there are a total of n items. And thus, a semaphore provides mutual exclusion while you access this buffer pool. And thus, empty and full semaphores are present that count the number of empty and full buffers. What is a reader-writers problem? So, in a reader-writer problem, we have two types. We have readers and writers. Readers are those who want to retrieve the data. Writers are those who read as well as write. They retrieve as well as manipulate data. So, we have to provide permission to a number of readers to read the same data at the same time. That is, multiple readers can read at the same time, but only one writer should write at the same time. Next is dining philosophers problem. In dining philosophers problem, we have 5 philosophers who spend their time eating and thinking. And all the philosophers are seated around the common circular table. There are 5 chairs, each for one philosopher, and also in the center of the table there is a bowl of rice, and there are 5 single chopsticks. And first, a philosopher is thinking, and whenever a philosopher thinks, philosopher doesn't interact with others, and from a philosopher gets hungry and pick up 2 chopsticks. So also a philosopher may also pick up 1 chopstick at a time. A philosopher can only pick up a chopstick that is not in the hands of others. And when a hungry philosopher acquires both the chopstick at the same time, the philosopher can then start eating. After eating, the philosopher then releases her chopsticks and then starts thinking again. What is deadlocks? So, suppose a process waits for a requested resource, and if this resource is not available, this is because this resource is held by some other process, and this process is also waiting for some other resource. So, it leads to a deadlock. Now, there are different conditions for deadlock. One is all these 4 conditions are necessary for deadlock to occur. That is mutual exclusion, hold and wait, circular wait, and no preemption. What is a resource allocation graph? Resource allocation graph, it can be used to graphically describe or graphical representation of a deadlock. A resource allocation graph would have a number of edges and vertices. And there are different types of edges such as assignment edge, request edge, etc. And in this resource allocation graph, we check whether there is a cycle or not. If there is a cycle present in the resource allocation graph, then which means a deadlock has occurred in the case of single instance of each resource. Next, what are some deadlock prevention techniques? Deadlock prevention. So now to prevent a deadlock, you can break any one of the conditions that is necessary for deadlock to occur, such as mutual exclusion, a hold and wait, circular wait, no preemption. Next, what is a safe state and what is a safe sequence? System is said to be in a safe state if there is a safe sequence, and when there is a safe state, there can be no deadlock. So, when can we say the safe? A sequence of processes is said to be in a safe state or in a safe sequence if the current allocation state for each process, the resources is such that it can be satisfied by that process plus held by all the other processes Pj. So what is deadlock avoidance algorithms? Deadlock avoidance algorithms are those that would make sure that a deadlock would never occur. So here we can make use of resource allocation graph when there is a single instance of each resource, then Banker's algorithm and safety algorithm. What are the basic functions of an operating system? Operating system, it controls, coordinates the use of hardware, acts as a resource allocator, manager, allocates resources, and controls the use of programs, prevent errors, and the improper use of the computer. Then explain about a processor, assembler, compiler, loader, linker, and the functions executed. So first is processor. Processor is a part of the computer system that executes instructions. Processor also called as a CPU. Next is assembler. Assemblers are programs that takes basic instructions from the computer and converts them into a pattern of bits that is then used to perform different operations. Next is compilers. Compilers are special types of programs that process statements written in a particular programming language in order to turn them into the machine language or code. Loaders. Loaders are components that would locate a given program that is in an application part of the operating system that is stored in an offline storage such as a hard disk, and then loads it into the main storage or memory. Linkers are those that perform the linking of libraries with object code in order to make the object code into an executable machine code. So loader would locate a given program in the secondary storage or hard disk and load it into the main memory, whereas linkers would link the libraries with the object code to convert this object code into an executable machine code. Next, what are real-time systems? Real-time systems are those that have rigid time requirements and can be used to run real-time processes. The difference between hard real-time, soft real-time. Next is virtual memory. Next is virtual memory is a hardware technique. System appears to have more memory than it actually does. This can be done by time sharing, physical memory, and storage paths when they are not being used. Next is what is cache memory. Cache memory is a random access memory or RAM that the computer microprocessor can access much more quickly rather than accessing it from the regular RAM. So as a microprocessor or the CPU processes data, it would first, whenever there's a request made, it would first check whether it is present in the cache memory, and if it finds it, it can help to save time. Otherwise, it have to perform more time consuming reading of data by taking it from the main memory.